All right, we are next going to talk about relations and functions. First, relations, and go through some definitions, and then talk about how functions are special kinds of relations. So that's where we're heading today. So, what is a relation? A relation is a set of ordered pairs. You can see relations expressed all kinds of ways. Um, let's see. Let me write down a couple of different possibilities of how you can see this. First, let me get my little pen working here. There we go. You could simply see a set of ordered pairs the way it sounds. Like you could see set braces. You could see ordered pairs like 2, 5, 4, -3, -1/2, 2006. Yeah, just a set of ordered pairs like that. That is a relation. Or you could see these sets of ordered pairs expressed some other ways. You might see a set of ordered pairs that's expressed in a chart of some kind, where it shows you the x and y values in a chart form instead of in the x, comma, y parentheses form. So it might list, like in this case, the x's across the top, and then the y's across the bottom there. So that's another way you can see it expressed, but it's still a relation, as long as you have the x and y ordered pairs there. Or you could even see graphs. If you see a graph like this is still a set of ordered pairs. It's continuous, it's smooth, so there's infinite ordered pairs compared to over here. Here you've got what, 3 ordered pairs on this one. Then over here you got infinite ordered pairs. But there's still a relation because you can still start listing those ordered XY ordered pairs. So that's what we've got as far as what is a relation. Now in a relation, when you're looking at those XY ordered pairs, the domain is the name for the set of all the X values, and the range is the name for the set of all the Y values. So if you have a relation such as this, like 6, 3 and -4, 7 and 8, -100. In that case, the domain would include the 6, the -4, and the 8. And then in that case, the range would be the set of all the Y values, and that would include the 3, the 7, and the -100. But again, your relation doesn't have to just be a list of ordered pairs. It can be a graph, a continuous graph with lots of ordered pairs. So you could have something like this. Okay, here's your XY axes. And let's see, that goes up to 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Let's say you have an ellipse. Okay, nice and continuous. That's supposed to be smooth. Sorry, I'm not a very good artiste. But you've got a relation there because where you drew the ellipse, those are all ordered pairs. They're connected and next to each other, connected smoothly. They're all ordered pairs, so that is a relation. And then the x values and y values can be listed, but since it's infinite ordered pairs, you don't want to actually sit there and list them out because you'll be here a whole lifetime and still not even be close to being done at all. So what you can do is use something called interval notation. Interval notation will allow you to express the fact that like your x values go anywhere from -4 to 4, your y values go anywhere from -2 to 2. So you've got all reals. Here's your set notation, all real numbers. The x values are all real numbers from -4 to 4. Well, there's something called interval notation where you can say, all right, the smallest value possible is the -4. The largest value possible is the +4. And you write it kind of like an ordered pair. You put the smallest value, largest value, and you put a comma. And this is gonna say is that it includes every possible real number in between. Every integer, every decimal, anything you can think of between these two numbers is included. And then since the graph actually includes -4 and includes +4, you put little brackets here. Those brackets say, okay, -4 and 4 are numbers in that interval, but also everything in between. And then for the range of that, you got all real numbers from -2 to 2 for the y values. So you would write -2, comma 2, and then since it actually includes -2, includes +2, put little brackets. Brackets include those endpoints. Parentheses don't include endpoints. So that's domain and range for you. Okay. Then when we get to functions, we're still talking about relations. Remember, relations is just a set of ordered pairs. A function is a special kind of relation where every element in the domain, so every x value, corresponds to exactly one element in the range. So each x has exactly one y that goes with it. If you started listing out your ordered pairs, your x's do not repeat. Repeat in the list of ordered pairs. So that's a quick test. You know, if your x values repeat, then you know, hey, this is a relation but not a function. If your x values don't repeat, then you've got a function. So the x values, those are the independent variables. You know, that's usually what you're plugging in numbers for. And then the output, the y value, is the y value, dependent variable. You'll have exactly one output. So basically, if you plug in something for x, you'll only get one y. If you plug in a real number for x, as the input, you will get one result for y, the output. So, so here's some examples. Let's say you have set of ordered pairs 2, 5, 3, -1. I'm just making up stuff. -5, 6. Okay, this is a relation, set of ordered pairs, and each x, you got x value for 2 only has a y value of 5. X value of 3 only has a y value of -1. X value -5 only has y value 6. So this is a function. If you have something like this, this relation is still a function too. And you might be like, but wait a minute, I see that -10 repeating. The -10 is a y value that repeats. That's okay. right now. We're looking at just whether the x values repeat. And the x values of 7, 8, 11, and 6 have no repeats in there. So it's okay if different x values have the same output, but it's not okay if the same x value has multiple outputs. That's the key with functions. Now later in the course, we're going to talk about whether functions are one-to-one, and then it'll be important to decide, do the y values repeat. But for now, we don't have to worry about that. And then here's an example of one that's not a function. This is a relation, not a function. Because you have 13 here, and you also have 13 here. So the x value repeated. It's like, oh, not a function. So the input of 13 had two outputs, a 3 and an 8. Now, if you're examining the graphs of relations, and you want to quickly decide if you have a function or not, there's something called the vertical line test. If you sweep a vertical line across the graph and it only crosses, up to one point at a time, then you're good. You have a function. But if the vertical line touches more than one point at a time, not a function. Okay, so let's see here. Let's say you have a graph that looks like this. Okay, this is a relation. It is a set of ordered pairs. And as you go across, if you take a vertical line and sweep it across the graph, it will only touch one point at a time. Passes the vertical line test. I'll call it the VLT. So this is a function. But if you have something like this, I'm trying to think of something fun to do, but just do a sideways parabola. You have something like this. This is a relation. This fails the vertical line test. Fails the VLT. Because like right here, vertical line crosses 2 points at a time. Vertical line can only cross, no more than 1 point at a time, but after you hit the vertex here, from then on, a vertical line crosses 2 points at a time in that graph. So this is not a function. Okay, now let's say you have some functions. I just want to tell you a little bit about some basics about functions, including notation and how to evaluate a function. Often, if a relation is a function, you'll sometimes see a special notation to replace y. You might see this, f of x. This does not mean f times x. The parentheses here do not mean multiplication. With function notation, the f is the name of the function. And then what's in parentheses? That's what's going in for the independent variable. So like you could have f of x equals 3x minus 7. Okay. So the f, it's the function f, and then the x is your independent variable. And that's the same thing as saying y equals 3x minus 7. You can use other letters too. You could say g of x equals 3x squared plus 6x minus 9 or something. You can use other letters. Get other names. You can use capital letters, lowercase letters. You could say like cost function, c of x equals 15x plus 2, something like that. So different letters. Now, if you see something like this, like let's say you have f of x equals 3x minus 7, and you're asked to find f at 2. Well, this goes in for the independent variable. So f at 2, you're going to say 3 times 2 minus 7. So 6 minus 7, which is -1. So that 2 is your x, and that -1 is your y. So 2 comma -1 is an ordered pair solution for f of x. Also, if you're given a function, let's say you're given something like 3x plus 2y equals 11, and you want to put in notation, function notation, solve for y. So 2y equals -3x plus 11. Y equals -3x plus 11 over 2. And then replace y with f of x. So you have f of x equals -3x plus 11 over 2. Okay. So that's a little bit about functions. You've got plenty of those to practice, including determining if it's a function, deciding on domain and range, evaluating the functions. So you got lots of practice to do with that, and you're going to be seeing a heck of a lot of functions throughout this course. So have fun with it. Thank you for joining us.